Okay, we're back, and we're going to talk about the individual components up here that make up our system. Our This would be called maybe this would be referred to as the entity, and these would be called the components. So under all of this, we have you can click on the individual components and it will show you what they consist of. And we will briefly go through them here so that you can have a better understanding of what's going on. Okay, so we will start with, we've already been here, went through this and kind of explained what the entity was and what the components were and what signals are. Remember, signals are kind of like pipes. So we did that. Now let's go and look at some of the components and what's actually going on behind the scenes, because I've just listed the component here, but this doesn't actually tell you how this component works. It just shows you what the inputs and outputs of the component are. So let's go look at some of these and see what's going on here. We have the 8-bit data pass delay. Okay, this is a simple flip-flop device with 8 flip-flops in it, and it's located right here. I called it delay timer, and as you can see under it, it's using 8 individual flip-flops. So let's look at this. So delay timer, here it is. Here's the entity description right here. Fast in, meaning this is going to be connected to just the signal from the clock. Update now, which is going to be a more periodic signal that's going to come from a clock that's been slowed down. And this right here is going to be the sample that's only updated when the slower signal here is red, so is high. So those are my 2 inputs, and that's going to be my output. And if we look at what's going on here, we can read look at the architecture and look at the components under this. So this is our entity, and we have one component. That's going to be a flip-flop, and we can go look at what a flip-flop is when we start getting into over here underneath of the 8-bit data pass delay. So you can see here we have we've included our component here, and we're instantating that component 8 different times, and I call it flip-flop 1, flip-flop 2, flip-flop 3, flip-flop 4, all the way down to 8. So, or you can think of it as this being 0 to 7. So what I've done here is I have we need to go look at what the actual flip-flop is doing to understand what this is doing. So let's go over and look at the flip-flop. Okay, so I just clicked on the flip-flop and brought this up. Now, this is our entity. This is the flip-flop, and it has 3 inputs and 2 outputs. We have a data in, so that means we're going to have a high or a low, a 1 or a 0 coming in. And then we have the clock, which is telling it when to flip and flop, meaning goes from meaning it will update its output based on the input. And then we have our enable, which says, okay, you can go ahead and do that. So it can get a clock all at once, but if it's not enabled, it's not going to update. And then we have our data out, and we have the inverse of that, not data out. So here's how this works. We come down here and let's describe it. And here we go. So this is one of the lowest level components. Nothing else makes up this component. It doesn't have any sub-entities or anything like that. It's just pretty simple. It says we use a process here. And this, we say begin. So process begin if rising edge of clock. And if you know anything about how this works, you know that you want to look for the rising edge of clock for a flip-flop, and then we can go ahead and follow through if rising edge of clock, and basically and if enable is equal to 1, meaning it's high, then data out is going to get data in, meaning they're going to be the same. It's going to switch to whatever that is. If not, and then not data out gets not data in. So that's how this flow works. This is going to become whatever this is. And you end that if statement and end this if statement and end the process and end behavioral. So that's how I guess we'd call it maybe a subcomponent works. That's one of the lowest level components. So there's 8 of those individual guys that are all implemented in here. So you just define it once, and then you make 8 individual ones by specifying each individual component. Call this one, you specify it by writing, tell it what it is, and then instantate it. So it's a DFF, D flip-flop. And we've instantated it, and we've given it a name. There's 8 of them. And so what happens is each bit comes in, and it's going to fast in, and then update now, which is connected to our clock. Okay. And enable is 1. So remember, we're getting it. We connect it to a slow clock signal. So, and our data is our held sample 0. So this is 8 bits wide, and this is also 8 bits wide. And our not data out, we just stick that to open because we're not using the inverse of our data output. So, and we just do that a whole bunch of different times, well, 8 to be exact, in order to hit each of the 8 bits in and out. As you can see, 0 through 7 here. That's how you designate bits, unless you waste one, of course. So that right there is how we slow the data down. So basically we have 8 bits coming in, and that information won't be updated to the output unless it's told to. And then, so whatever the output is, it's going to hold that value until it's told to update. So in this, essentially, we're slowing down the refresh rate of our system, of our 8-bit signal, and then we use that to we pipe that in or connect that to all 8 bits to our 7-segment display, which is what I'm going to go over next. So here's our 7-segment display. I got a lot of stuff that's commented out, and it uses all 3 of these libraries. And here's our entity. Here are the oh, I got a little, oops. Let's see if we can make this look a little prettier. So this got a little, this has our entity, and it consists of its own components here and here, clock division and also I don't know what this is because I actually didn't make it, but this section as well. So this can be, this file is probably very common and can be researched outside of this tutorial. It was something that is provided in class, and it can be, you can go through here and try to figure out what the code is doing on your own. I'll give you a basic idea of how it works. It basically works off of persistence of vision, meaning if you see something that blinks on and off fast enough, it looks like it's just on all the time. It's kind of like the lights in your own house. They're actually going on and off, if you live in America, 60 times a second, but it looks like they're just constantly on because our eyes don't process that fast. So via persistence of vision, you have on our LCD readout, we have 3 individual digits, and it reads from 0 to 255. And what's happening is each one of those digits is being lit up at a separate time. It's only one digit at a time. So in actuality, when you look at it, it looks like all 3 are lit, but it's only one at a time. It's just going through and cycling them so fast. And think of all the math that has to go into that. You have to have a certain set of segments of your digit lit, and then you supply an anode, and so that anode lights up that digit, and then that turns off, and then you got to calculate and display the next one, and so that goes through and it displays the next one, and then it does the third digit, and then it just keeps doing that, and only one at a time, but it looks like all 3 of them are on at a time. So that's part of the anode and I think it was called display enable and segments. Yeah, so the anode here and the segments here. So anyways, that's our 7-segment display readout. It's somewhat complex, and this was a piece of software that I reused, so have fun looking through that if you'd like to understand it better. Next, we're going to go into see, and you can see over here in the tree that the clock divider and the my conversion are 2 sub components of this entity. That is a subcomponent of this entity. Okay, anyways, so that's a 7-segment display, and then we have bar meter here. So bar meter's the last thing we'll talk about here, and we could look at clock division 2, even though that was a reused bit of code that I haven't fully understood yet. So the bar meter, I originally tried to do 16. I divided the 0 through 256 into 16 pieces, which turns out it's just 16 is the would be a segment of that 16. So, but this didn't work for some reason. It was giving me an error for some of the greater numbered LEDs, meaning 12 through 15. So I had to abandon this idea for better resolution and just turn it into 8 bits, which is what we have here. So these have 32 bits. These are 32 bits wide. They shift every 32 bits. So basically 0 through 32 would be the first LED on. Right here you can see the output. So 7 LEDs off and 1 LED on. So, and then right here we want anything between this number and the next number. So there will turn on the next one. So that'd be like from 33 to, or equal to 30 to, so larger than or equal to 32 up to 64 for that. And that turns on the next LED. So we do that 8 times until we get to 255, and then we have all the LEDs on. And we put in an else. Just give me solid zeros if it's some other value, which I have noticed at the top of 255, it will actually go to this value for some unknown reason. I don't know how what's happening there with the ADC or what. So that's basically how that's going. We have the process, and we have we're measuring something here. Okay, it's the same thing. It's just if it's between this number and this number, then we turn on the first one. So you have to include that in your parentheses. You should know a little bit about VHDL. You should be able to copy this block of information to start any process, and just know that whatever you're measuring or looking at goes in this process parentheses here. And then you could write stuff like this, if else statements, and all sorts of different cool things. So there's that. And let's see, lastly we'll go up and do the clock division here. So this is another piece of code. I'm going to double click it to open it, that I don't entirely understand. I mean, I could look at it and speculate, but it's just this chunk of code here. It was provided to me in my class, and it works for basically slowing a clock signal down. So it gets a clock signal in, and it gives you a slow clock signal out. Or a clock in and a slow clock out. So there's that. You can see right here it was created by Brian Mealy, Ratner Engineering. Who knows? So this is all just a stock file. I haven't touched it all. I just used it because I know how to access it. So that is, I believe that was everything under the main entity there, except for this. So this right here is the XDC, and I'll show you how to start that and add an XDC and make it work, an XADC, excuse me. So here, if you don't have this already in here, and for some reason the file, you can't get it to load the file from the files that I've provided, what you want to do is you want to come here, and what you can do is you can go over here to, by the way, if you can't get to this pane, usually it's over, it might be hidden over here. You want to click on it over here to open it, and then you go to, you'll have a bunch of different stuff over here, and it may be collapsed like this, so you won't see this big old long list of things. You may see something more like this. And what you want to do is you want to come over here, and under Project Manager you want to get an IP catalog. And click on that. And it brings up this right here, IP catalog. Okay? So you got all this stuff you could dig through to try and find stuff, but I've noticed it's easier, and somebody showed me, you could just search it up here. So what you want to search for is XADC. It stands for Xilinx ADC. And what happens is that will bring up this right here, and you can click on it. And I don't know what's going to happen because I already have one in my setup, so I don't know if it's going to try and add an extra one right now or what, or just bring up the one I've already modified. And it looks like it's just brought up the one that I've Oh no, it doesn't look like it. It brought something else up. Okay. Alright, well then I'll run through this and show you. So, and then I'll just cancel. So in this, you want to use DRP for this kind of setup. AXI 4 is some kind of protocol that I have not learned yet. But for something like this, just a differential pair that you're going to be looking at, the difference between 0 and 1 volt on two separate wires. This right here, so you use DRP single channel mode, and then other things you'll want to change on here is you want to have it in continuous mode, and I believe that's everything. Let's go over here to ADC setup. So over here you want to get rid of all your enable calibration averaging. That's good, keep that. But you want to get rid of your you want to have that. Okay, this is an alarm, so don't touch this page. Alarms, get rid of everything. You don't want any of this stuff. So you notice it'll get rid of stuff over here for you. Channels, just go to 14 because that works. And that channel 14, that's the one that we're going to have, we're going to be using for the second set of pins on the board, second set in. So bottom's negative and the top's positive, so maybe show that in a video a little bit later. So anyways, enable, you don't want bipolar mode or this. You do need, I'm trying to see why it's got so many. What happened with, oh, get rid of that. Single channel. Summary. Why is it so huge? It's showing everything and it shouldn't be. Huh. Okay, well, looks like I don't know what I'm doing. DRP continuous mode, no. Okay, that's from what I remember. This used to be a lot smaller, so but that should be everything. Those panes should all kind of match, and I believe you can leave these set here. So yeah. Oh. Okay. Yep. So like that, just how you've seen all that. That's what you want for your X80C. And what'll happen is when you say go, is if you were to say okay, it would bring up a file that says, would you like to instantate this? And you say, or it'll bring up a dialog box and you say yes, and then you would basically follow the directions. And there's also provided documentation and other tutorials for loading the X80C, or for including it. Let's see here. So when you click on the X80C, this is the file that shows up, and it has a disclaimer here because this is an IP, an intellectual property. You can't actually change anything. So if I came in here and I selected that and I hit backspace or delete, it doesn't do anything. Nothing I press does anything. This file does not respond. It is locked. But they've included all the, I believe this is all the source code. I could be wrong. They've included everything here so that you can maybe see how it works and what's underlying behind it. So you definitely need to be able to read this and read all this stuff. And But all that information is also available in the other documentation I've included in the tutorial. So, let's see what we want to look at next. Actually, I'll end this video here and we'll start another one in a second. And you'll be able to see that.